everyone, good afternoon. We're from Gang of Four, and my name is Amira Chairunisa Effendi. Together with my teammates Gabriel Angeline, Unizoe Lyle, and also Maria Yastika, here today we're going to present our analysis on problem 2 given by Mas Rezi. So moving forward, we're gonna start by Gabriela Angeline.
Okay, thank you, Amira. So, first I would like to introduce about today. Clustering is a type of unsupervised machine learning technology that is used to mine the internal similarity of data and divide the data set into different subsets. The purpose of clustering is to discover the internal grouping of unlabeled data. There are many different ways to cluster data, but today we will use the k-means and principal component analysis approaches to cluster the data for this investigation. The purpose of conducting the study is to find the most appropriate cluster type for the Excel file containing data on the number of flights taken between 2017 and 2022. Our research question is, which clustering method is more effective in processing the flight data, k-means or PCA? The pandemic caused by the COVID-19 virus had tremendous effect on the airline sector. A number of nations put into place travel restriction and lockdowns, which resulted in a decrease in demand for air travel. As a direct consequence of this, airlines were compelled to drastically cut back their flight schedule. This resulted in severe financial losses for the numerous airlines, and as a result, some of those airlines were compelled to seek financial aid or declare bankruptcy. According to information provided by the International Air Transport Association, the number of passengers traveling throughout the world in the year 2020 was roughly 66% lower than it had been in the previous year. This drop was especially noticeable in the early months of the pandemic when air travel was virtually halted across a significant portion of the globe. In this research, we estimated the impact of travel restriction on the spread of COVID-19 in 48 airports using a clustering techniques. Examine the impact of the lockdown on transmission of COVID-19 on the network. We hypothetically simulated that k-means clustering will be most successful in generating observable clustering from the dataset.
Okay, moving on to the data where it is separated into two subchapters. The first is data source and next is variables of interest. So from the data source, the data obtains a number of flights ranging from the year 2017 to 2020. From 2017 to 2020 are categorized as flights before COVID-19, and 2021 until 2022 was COVID-19, and it consists of domestic and foreign airports with a total of 48 airports. As for the variables of interest, the major variable of interest is the quantity of flights and that depart from each airport and arrive at the Abdul Majid International Airport in Lombok. The distance of the airport, measured in kilometers from Zainuddin Abdul Majid International Airport Lombok, is an extra variable of interest that has been added to the facts that have been presented. Moving on to the next is hypothesis. And from the research, we predict that k-means clustering will be most successful in generating observable clusters from the dataset. We believe so because the dataset can be considered a small dataset. And from the dataset, we can still observe a few patterns without testing the data first. Hence, we believe k-means clustering will fit the data the most because k-means will help us to find the hidden patterns that we cannot observe. Moreover, we also predict that there will be a significantly more cluster of aircraft that fly at closer distance compared to the longer one. This is because flights with closer distances are much easier to serve compared to the longer ones.
And moving forward, in here, we're going to discuss the methodology that we use throughout our analysis. First, we did a data processing in which here, us as the researchers will change the nature of the existing variables from characteristic variables to numerical variables. This pre-processing is done with the aim that the data used can be further processed into clustering analysis. And then we're going to do the data analysis by first doing the k-means clustering. As previously stated, k-means clustering identifies groups in the data with the number of groups indicated by the variable k. The method assigns each data to point one of k groups based on the specific attributes. The algorithm works by iteratively assigning each data point in the cluster with the nearest mean and then recalculating the means of each cluster. The process is then repeated until the assignments of points to cluster are no longer changed or a maximum number of iterations is reached. In here, as you guys can see the before k-means data and then after k-means data. And then on to our second data analysis method, which is principal component analysis or PCA. PCA is simple to compute because it is merely based on linear algebra, which does not require a significant amount of memory to carry out on computers. And then when machine learning algorithms are taught using principal component analysis or PCA rather than the actual dataset, convergence occur more quickly. In conclusion, PCA helps to alleviate the difficulties brought on by high-dimensional data. By employing PCA in advance to cut down on the dimensionality of the training dataset, we are able to prevent the prediction algorithm from being overly accurate. Despite this, we are aware that there will be certain restrictions in the execution of PCA due to the fact that Angkasa Pura Lombok dataset is not necessarily a high-dimensional one. We will use PCA to determine which main components of the dataset considers to be relevant, and this will subsequently be clustered.
And also, we're going to discuss the further discussion about the result. Okay, the first one is k-means clustering. The first step is we set the parameter k, and then the second step we have to determine the initial cluster center randomly here, and from the data in the form of rows equals to many k, and the columns equals to the number of variables used. And as a result, we import random define pusat underscore cluster underscore awal, and then return pusat underscore cluster underscore awal. And then the third step is we determine the distance between each data point and the cluster center. And by using Euclidean, we define a function to calculate the data distance between cluster and also the centers. And the fourth step, we assign data cluster based on the cluster center that is the nearest here, as we can see. And then we use this function to give the minimum and the index of that minimum, so we can assign data cluster based on the closest cluster center. And the fifth one, we have to calculate the average value of each cluster to update the cluster center. And in this case, we define the function here. And the sixth step is this function here defines the cluster change function, and it seeks the discrepancies in order to determine whether the cluster center has to be updated again. And the next step, we have to bring all previously established functions together to form cluster function, as we can see here. And then we define the k-means function itself and unify the previously created functions. And the eighth step, we have to test the dataset. And here, as you can see, by default, the head function in Python displays the first 5 rows of the data frame. And the next step is we have to plot the cluster. And as you can see here in the graphic, it is based on total flights, with the x-axis representing flight data for 2019 and the y-axis representing total flights. And because of the PCA results generated 2 most essential variables, the T 2019 and total flight were picked. And as observed in the plot, cluster 0 here contains 3 spots, the red dots here, with the highest score and the greatest number of flights. And cluster 1 contains 5 spots, as you can see here, the yellow dots with a modest value and a moderate total number of flights. And furthermore, there are several dots with the blue dots here on cluster 2, indicating a lower score and a small total number of flights. And the 10th step, we have to examine the number of iterations and the cluster members. And as we can see here, in the preceding plot, cluster 0 contains 3 airports with the highest score and total number of flights. As you can see, there is Soekarno-Hatta Airport, Ngurah Rai International Airport in Bali, and Juanda Airport in Surabaya. And next, as shown in the preceding plots, cluster 1 has 5 airports with a moderate score and a modest total number of flights. And then we move on to the principal component analysis, or PCA. And the first step is to import the PCA package from Sklearn, and then we specify the value of the components or most important variables that you wish to take. And then the XPC variable will be replaced by a new variable containing two most important variables according to PCA. And we have to remember that the main function of PCA is dimension reduction by taking the most important variables as many as the components. And by using PCA approach, the most relevant feature retrieved from the dataset Angkasa Pura Lombok are the 2019 feature and the total feature. And as we can see here, it shows the plot of the total flight. The x-axis is flight data for 2019, and the y-axis is total flights. And the two data points here were picked because the PCA findings give the two most essential variables.
Okay, moving on to the conclusion. So in this analysis, two methods of unsupervised learning are used. There are PCA and the K-means clustering. So based on the Angkasa Pura Lombok dataset, we are able to draw the conclusion that K-means is the most efficient method for building observable clusters. This is evidence that supports our hypothesis because, once again, the data that was used is not particularly high dimension and it is rather small. In addition, the findings from K-means clustering are in agreement with our second hypothesis, which says that there is a significant population of plants that go shorter distances.
Moving forward to the limitations, first, for K-means clustering, we were able to determine through the use of K-means that there was a correlation between the total number of flights to LOP and the distance that separated the airport and LOP. However, in light of the fact that we are aware that the distance isn't the only element that determines the total number of flights that arrive at the airport, there are also a lot of considerations. This could be due to the popularity of the air route in addition to the popularity of the destination. Because of economies of scale, there are more passengers on many long-distance flights. On the other hand, flights covering shorter distances are typically more expensive and, as a result, have a smaller customer base. And then onto the PCA, the dataset that we chose is not necessarily a high-dimensional dataset, and upon initial inspection, there were already some patterns that were discernible. Because of this, we could have used a more effective method instead of PCA, which produced a graph that was rather simple and constrained in its scope. In addition, the principal component analysis was only successful in extracting the first 8 observations of the dataset. We were only able to draw limited conclusions due to the fact that there is a limited quantity of data points, despite the fact that we were able to observe a pattern. Therefore, for our recommendations, as was previously mentioned, there are other factors than the distance that affect how many planes ultimately land at an airport. Numerous other factors can be used in the analysis. Therefore, it will be better if the study could incorporate more variables such as the air route's level of popularity. The PCA approach is unsuccessful because although we were able to observe a pattern, we were only able to make limited inferences due to the small number of data points. Therefore, the principal component analysis all extracted the first 8 observations from the dataset. Instead of PCA, a more effective approach might be utilized, a method that may build a simpler graph and limit its reach.